National Electrical Code Section 702.6 addresses the requirements for alternate power sources, such as generators, in emergency systems. Section 702.6 generally states that where an alternate source of supply is provided for emergency use by a separate generator, transfer equipment shall be provided to connect and disconnect the alternate source to the load. This implies the need for a mechanism that positively isolates the normal power source from the emergency power source during transfer, preventing the simultaneous connection of both. The key principle here is to ensure that the emergency power system operates independently of the normal power system, avoiding any possibility of backfeeding or paralleling. There are no exceptions to 702.6 that would permit an installation where transfer equipment doesn't adequately prevent paralleling of the generator set and utility power. Considering the 1990 National Electrical Code, while it might not have explicitly mandated break before make transfer switches, it did emphasize the importance of transfer equipment designed to prevent an inadvertent connection of the backup power source to the utility power. This implies that even under the 1990 code, installations relying solely on operating procedures to prevent paralleling would likely have been considered non-compliant, as they lack the positive isolation and safety mechanisms required to ensure electrical safety. Operating procedures alone are not deemed acceptable by the National Electrical Code as a method to prevent an inadvertent connection of backup power to utility power. National Electrical Code Section 702.6b further clarifies this point, stating that transfer equipment shall be automatic or semi-automatic and shall be designed and installed to prevent the inadvertent paralleling of normal and emergency sources. This reinforces the requirement for a physical or electrical mechanism that actively prevents the simultaneous connection of both power sources. In addition to the National Electrical Code, NFPA 70E, Standard for Electrical Safety in the Workplace, also underscores the significance of preventing inadvertent paralleling. This standard focuses on electrical safety in the workplace and emphasizes the need for safeguards to protect personnel from electrical hazards. Inadvertent paralleling can create dangerous situations, potentially leading to equipment damage, power outages, and even electrical shock hazards. To comply with the National Electrical Code, the existing installation should be replaced with compliant solutions. These solutions can include, firstly, dual-cut key interlocked breakers, which are a mechanical interlocking system that ensures only one breaker can be closed at a time, preventing paralleling. Secondly, break before make transfer switches, which are designed to disconnect one power source before connecting the other, ensuring a seamless transfer without paralleling. Additional considerations for National Electrical Code compliance can include 1. Proper labeling, which is clear and conspicuous labeling of all equipment associated with the emergency power system, including transfer switches, generators, and distribution panels. 2. Regular maintenance. Implementation of a routine maintenance program to ensure the reliability and proper functioning of the emergency power system, including testing of transfer switches and generators. 3. Coordination studies. Conducting coordination studies to ensure that overcurrent protective devices are properly coordinated to minimize the extent of power outages during faults. 4. Training. Providing adequate training to personnel responsible for operating and maintaining the emergency power system. 5. Documentation. Maintaining accurate documentation of the emergency power system, including wiring diagrams, equipment specifications, and maintenance records. In a generator system, several essential components work together to ensure reliable power during outages. Firstly, the generator itself, powered by diesel, natural gas, or propane, converts mechanical energy into electrical energy. Secondly, the automatic transfer switch, or ATS, monitors incoming utility power and automatically switches the load to the generator when utility power fails. Thirdly, the fuel supply system, which includes storage tanks and piping, provides fuel to the generator. Fourthly, the cooling system, typically a radiator and fan, prevents the generator from overheating. Fifthly, the exhaust system safely vents exhaust gases away from the generator. Sixthly, the control panel monitors generator operation and provides controls for starting, stopping, and adjusting generator output. Seventhly, batteries provide power to start the generator. Eighthly, the enclosure protects the generator from the elements and reduces noise. Ninthly, grounding ensures electrical safety. Tenthly, overcurrent protection devices, such as circuit breakers and fuses, protect the generator and connected equipment from damage due to overload and short circuits. When utility power fails, the ATS senses the voltage drop and signals the generator to start. Once the generator reaches its operating speed and voltage, the ATS disconnects the load from the utility power and connects it to the generator. When utility power is restored, the ATS automatically switches the load back to the utility and shuts down the generator. Proper maintenance is crucial for ensuring the reliable operation of generator systems. Regular maintenance tasks include inspecting and cleaning the generator, checking and replacing fluids and filters, testing the batteries, and inspecting the wiring and connections. In addition to the generator, the ATS also requires regular maintenance to ensure it functions properly. This includes inspecting the contacts, checking the wiring, and testing the transfer mechanism. Fuel supply systems also require regular maintenance to prevent leaks and ensure an adequate fuel supply. Storage tanks should be inspected for corrosion and leaks, and fuel filters should be replaced regularly. Cooling systems should be inspected for leaks and debris, and coolant levels should be checked regularly. Exhaust systems should be inspected for leaks and corrosion, and mufflers should be replaced as needed. Control panels should be inspected for damage and loose connections, and all controls should be tested to ensure they function properly. Batteries should be tested regularly to ensure they can provide sufficient power to start the generator. Enclosures should be inspected for damage and corrosion, and any necessary repairs should be made promptly. Grounding systems should be inspected to ensure they are properly connected and functioning. Overcurrent protection devices should be tested regularly to ensure they trip properly in the event of an overload or short circuit. There are several key safety considerations to keep in mind when working with generator systems. Firstly, always disconnect the generator from the utility power before performing any maintenance or repairs. Secondly, wear appropriate personal protective equipment, such as gloves, safety glasses, and hearing protection. Thirdly, never work on a generator while it is running. Fourthly, allow the generator to cool down before performing any maintenance or repairs. Fifthly, be aware of the hazards of carbon monoxide poisoning. Generators produce carbon monoxide, a colorless, odorless gas that can be deadly. Always operate generators in a well-ventilated area, and never operate them indoors or in enclosed spaces. Sixthly, store fuel safely. Store fuel in approved containers in a well-ventilated area away from heat, sparks, and open flames. Seventhly, follow all manufacturers' instructions for operating and maintaining the generator. Eighthly, be aware of the potential for electrical shock. Generators produce electricity, which can be dangerous if not handled properly. Always use caution when working with electrical components, and never touch bare wires or terminals. Ninthly, be aware of the potential for fire. Generators can overheat and cause fires if not properly maintained. Keep the generator clean and free of debris, and ensure that the cooling system is functioning properly. Tenthly, be aware of the potential for noise. Generators can produce significant noise, which can be disruptive to neighbors. Consider using a noise-reducing enclosure or placing the generator in a location where it will not disturb others. In addition to these safety considerations, it is also important to be aware of local codes and regulations regarding generator installations. Many jurisdictions require permits for generator installations, and there may be restrictions on the type and size of generators that can be installed. Always check with your local authorities before installing a generator to ensure that you are in compliance with all applicable codes and regulations. Transfer switches are essential components in emergency and standby power systems, providing a safe and reliable means of switching between normal and backup power sources. There are several types of transfer switches, each with its own advantages and disadvantages. Firstly, automatic transfer switches, or ATSs, automatically switch the load from the normal power source to the backup power source when a power outage occurs. ATS are typically used in critical applications where uninterrupted power is essential, such as hospitals, data centers, and emergency services facilities. Secondly, manual transfer switches require manual operation to switch the load from one power source to another. Manual transfer switches are typically used in less critical applications where a brief power interruption is acceptable, such as residential homes and small businesses. Thirdly, static transfer switches use solid-state devices to switch the load from one power source to another. Static transfer switches are extremely fast and reliable, and they are often used in applications where even a brief power interruption cannot be tolerated, such as critical medical equipment and sensitive electronic devices. Fourthly, open transition transfer switches briefly interrupt power to the load during the transfer process. Open transition transfer switches are the most common type of transfer switch, and they are typically used in applications where a brief power interruption is not a concern. Fifthly, closed transition transfer switches momentarily parallel the normal and backup power sources during the transfer process. Closed transition transfer switches are more complex and expensive than open transition transfer switches, but they provide a seamless transfer of power without any interruption. Sixthly, soft loading transfer switches gradually transfer the load from one power source to another, minimizing stress on the generator and connected equipment. Soft loading transfer switches are typically used in applications where large loads are being transferred, such as industrial facilities and commercial buildings. When selecting a transfer switch, it is important to consider the specific requirements of the application. Factors to consider include the criticality of the load, the acceptable amount of power interruption, the size of the load, and the budget. It is also important to select a transfer switch that is compatible with the generator and other components in the power system. Transfer switches should be installed and maintained by qualified electricians in accordance with all applicable codes and regulations. Proper installation and maintenance are essential for ensuring the reliable operation of the transfer switch and the safety of personnel. Regular maintenance tasks include inspecting the contacts, checking the wiring, and testing the transfer mechanism. Transfer switches should also be tested periodically to ensure they function properly in the event of a power outage. In addition to the type of transfer switch, it is also important to consider the features and options that are available. Some transfer switches include features such as remote monitoring, automatic testing, and surge protection. Remote monitoring allows users to monitor the status of the transfer switch from a remote location. Automatic testing allows the transfer switch to be tested automatically on a regular basis. Surge protection protects the transfer switch and connected equipment from damage due to power surges. By understanding the different types of transfer switches and the features and options that are available, users can select the best transfer switch for their specific needs. Proper installation and maintenance are essential for ensuring the reliable operation of the transfer switch and the safety of personnel.